High above us, a shining beacon circles our planet. This is the International Space Station, or ISS. It is a testament to human ingenuity and international collaboration. The ISS is a science laboratory, an observatory, and a home away from home for astronauts. It teaches us about living in space and helps us unlock the secrets of the cosmos. The ISS is a marvel of engineering, a structure assembled piece by piece in the unforgiving environment of space. It comprises modules where astronauts live and work, vast solar arrays that capture the sun's energy, and docking ports for visiting spacecraft. From this unique vantage point, the ISS offers breathtaking views of Earth. It also provides a platform for conducting experiments in microgravity, an environment impossible to replicate on Earth. The knowledge gained on the ISS benefits all humankind, advancing fields like medicine, materials science, and our understanding of our planet. The ISS is more than just a machine, it's a stepping stone to our future in space. It represents a sustained human presence in orbit, a testament to our boundless curiosity and our drive to explore the universe around us. The ISS wasn't built in a day. Imagine assembling a complex jigsaw puzzle, not on a table but while floating in space. That's the challenge of building the ISS. Each module, each solar panel, each truss was carefully transported from Earth and meticulously connected in orbit. The station's modules are like building blocks. Each one has a specific purpose, such as living quarters, laboratories, or storage. The modules came from different countries, showcasing the global collaboration that made the ISS a reality. Stretching out like giant wings are the station's solar panels. These panels harness the sun's energy, converting sunlight into electricity that powers the entire station. They are crucial for providing life support and running scientific experiments. Docking ports act as gateways to the ISS. These are specialized modules that allow visiting spacecraft, like Soyuz capsules and SpaceX Dragon, to attach to the station. Docking ports are essential for bringing new crew members, supplies, and experiments to the ISS. The ISS is a symbol of international cooperation, a shining example of what humanity can achieve when we work together towards a common goal. Imagine floating instead of walking, seeing the sunrise and sunset every 90 minutes. That's life on the ISS, a unique and challenging environment. Astronauts follow a structured routine to stay healthy and productive. Their day is filled with conducting experiments, exercising to combat muscle and bone loss, and maintaining the station. Simple tasks like eating and sleeping require adjustments in microgravity. Food comes in special packages and needs to be prepared carefully to prevent crumbs from floating around. Sleep stations have restraints to prevent astronauts from drifting around while asleep. Living in close quarters with colleagues from different cultures requires adaptability and teamwork. The astronauts on the ISS rely on each other for support and companionship. Despite the challenges, astronauts often describe their time on the ISS as an awe-inspiring and life-changing experience. They are pioneers, pushing the boundaries of human exploration and expanding our knowledge of the universe. Why doesn't the ISS fall back to Earth? The answer lies in a delicate balance between gravity and orbital velocity. Picture a ball being thrown horizontally. Gravity pulls it down, but the ball also travels forward. The faster the throw, the farther the ball travels before hitting the ground. Now imagine throwing the ball so fast that as it falls, the Earth curves away beneath it at the same rate. That's essentially what the ISS is doing. It's constantly falling towards Earth, but moving sideways so fast that it continuously misses the planet. This is the essence of an orbit. Gravity provides the inward pull, keeping the ISS from flying off into space. Meanwhile, the station's velocity, about 17,500 miles per hour, keeps it moving forward, tracing a curved path around our planet. This delicate dance between gravity and velocity is what keeps the ISS, and indeed all satellites, in orbit. It's a testament to the elegant laws of physics that govern our universe. Section 5. The Sun's Embrace. Gravity in our solar system. Just as Earth's gravity holds the ISS in orbit, the Sun's gravity governs the motion of planets, asteroids, and comets in our solar system. The Sun is a massive star, containing over 99% of the solar system's mass. This immense mass gives the Sun a powerful gravitational pull reaching far out into space and holding all the planets in their orbits. Think of it like a cosmic dance floor with the Sun as the lead partner. Its gravity dictates the steps, guiding the planets in their elliptical paths. The closer a planet is to the Sun, the stronger the gravitational pull and the faster it needs to travel to maintain its orbit. For example, Mercury, the closest planet to the Sun, zips around in a quick 88 Earth days. In contrast, distant Neptune takes a leisurely 165 Earth years to complete one orbit. The Sun's gravity is the invisible hand that shapes our solar system, keeping everything in its rightful place and driving the celestial ballet we observe. Section 6. The Pull of Matter, Understanding Gravity. Gravity is a fundamental force in the universe. It's the invisible force that attracts any two objects with mass towards each other. The more massive an object, the stronger its gravitational pull. Think of a bowling ball on a trampoline. It creates a dip in the fabric, and if you roll a marble nearby, it will curve towards the bowling ball. Similarly, massive objects like the Sun or Earth create a dent in the fabric of space-time, causing nearby objects to be drawn towards them. This is a simplified way to visualize Einstein's theory of general relativity, which describes gravity as the curvature of space-time caused by mass and energy. Distance also plays a crucial role in gravity. The farther apart two objects are, the weaker the gravitational force between them. This is why the Moon's gravity affects tides on Earth more strongly than the Sun's gravity, even though the Sun is much more massive. Gravity is a universal force, acting on objects of all sizes, from planets and stars to you and your cup of tea. It's what keeps our feet on the ground, what holds the Moon in orbit around Earth, and what shapes the grand structure of the universe. Section 7. A Cosmic Balancing Act, Forces in Orbit. Objects in orbit like the ISS or the planets in our solar system are engaged in a constant tug-of-war between gravity and their forward motion. This balance of forces is what keeps them from flying off into the vastness of space or plummeting towards the object they're orbiting. Imagine swinging a ball on a string. The string acts like gravity, pulling the ball inwards, while the ball's momentum tries to carry it away in a straight line. The result is a circular path, with the ball constantly changing direction due to the inward pull of the string. Similarly, in orbit, gravity provides the inward force, constantly pulling the object towards the center of the celestial body it's orbiting. This inward pull is counteracted by the object's forward velocity, which is always trying to carry it away on a tangent. This delicate balance between the inward pull of gravity and the outward push of inertia results in a stable orbit, allowing planets, moons, and spacecraft to maintain their celestial paths. Section 8. Perpetual Falling, the ISS in Motion. The ISS isn't actually floating in space, it's in a continuous state of freefall. But it's a controlled freefall, carefully orchestrated to keep the station in orbit. Imagine stepping off a diving board. As you fall, you experience a brief period of weightlessness before hitting the water. The ISS is perpetually experiencing this same sensation of free fall as it constantly falls towards Earth. However, the station's incredible speed prevents it from crashing into our planet. It's moving so fast horizontally that as it falls, the Earth curves away beneath it at the same rate. This continuous freefall is what allows astronauts on the ISS to experience weightlessness or microgravity. It's a unique environment that provides valuable opportunities for scientific research and a glimpse into the sensation of space travel. Several factors can affect the ISS's orbit, including atmospheric drag, the gravitational pull of the Sun and Moon, and even the pressure from sunlight. To maintain its altitude and prevent it from slowly spiraling back to Earth, the ISS periodically uses its thrusters for small boosts. These boosts, carefully calculated and executed, ensure the station remains in its designated orbit, continuing its mission of scientific discovery and international collaboration. Section 9. Beyond the Horizon, Advanced Orbits. While the ISS circles Earth in a relatively low orbit, there are other types of orbits with unique characteristics and applications. One such orbit is the geostationary orbit, located approximately 22,236 miles above the equator. Satellites in geostationary orbits take precisely 24 hours to complete one revolution around Earth, matching our planet's rotation. This synchronous movement makes them appear stationary from a fixed point on the ground. Geostationary orbits are particularly useful for communication satellites. Since they remain above the same spot on Earth, we can point our satellite dishes at a fixed location in the sky for uninterrupted communication. Another fascinating concept is gravity assist, a technique used by spacecraft to gain speed by stealing a tiny amount of energy from planets or other celestial bodies. Imagine a spacecraft approaching a planet from behind. As the spacecraft gets close, it's pulled along by the planet's gravity, increasing its speed. Like a slingshot, the planet's gravity flings the spacecraft on a new trajectory at a higher velocity. Gravity assists are incredibly valuable for long-distance space missions, allowing us to send probes to the outer reaches of our solar system and beyond using less fuel and time. Section 10. Expanding our reach. Understanding the ISS and the principles of gravity is paramount for our continued exploration of space. The ISS serves as a testament to human ingenuity. It showcases our ability to live and work in space for extended periods. The lessons learned from building, maintaining, and conducting experiments on the ISS are invaluable for future missions, including establishing a permanent presence on the Moon or embarking on a crewed journey to Mars. Gravity is the invisible force that shapes our universe, from the orbits of planets to the structure of galaxies. By comprehending its principles, we can navigate the cosmos, design efficient spacecraft trajectories, and unlock the secrets of the universe. As we venture further into the cosmos, the knowledge gained from the ISS and our understanding of gravity will be our guiding light, propelling us toward new frontiers and expanding our reach into the vast expanse of space.